Okay, hello. So for today's video presentation, we will be discussing homogeneous equation with constant coefficient. So this is to recall that homogeneous equation or equation of this given format, but then uh, if the g of x is equal to 0, then that makes it homogeneous. But if it is not equal to 0, that makes it as a non-homogeneous equation. So as we can see here, actually these two examples that we have here are non-homogeneous equation. Okay, so when we say homogeneous equation, so we could have a y double prime plus 2y prime. So plus y is equals to 0 is homogeneous. But in this case, so we have this negative 1, so it serves as the g of x here, so that makes it as a non-homogeneous. So similarly, so if we want the second equation, so this 2 is the g of x, so which is not equal to 0, so that makes it as a non-homogeneous equation. So the equivalent homogeneous equation for this is the third derivative of y, so with respect to x, plus the first derivative of y with respect to x would be equal to 0. So these are considered as the homogeneous equation, and then the other two as a non-homogeneous equation. So in solving or finding the solution for homogeneous equation, so it falls under three cases. So we start with a second order differential equation. Okay, so second order differential equations. So in this case, so there are two roots that are involved, but then the two roots could be classified into three. So the first one would be distinct roots. So that means the first root is not the same as the second root. So those are real roots. And then for case 2, the roots are repeated. So that means the two roots are just the same real roots. And for the last case, which is for case 3, so the roots are complex roots. So it has the real part and the imaginary part. So given that we have this format, a y double prime plus b y prime plus cy is equals to 0, so which is a second order homogeneous equation. And then so for order 2 differential equations, so we can classify whether that's case 1, case 2, or case 3. So by taking the relation between the b squared and 4ac. Okay, so in this case, so the coefficient of the second derivative is a, the coefficient of first derivative is b, and then the coefficient of y is considered to be c. So getting the mathematical relation of b squared and 4ac, so would classify as, or will tell us, so what would be the case for that given differential equation. Okay, so how do we write the solution? So again, so there are two solutions. Okay, so there are two solutions. So for a second order differential equation, so in this case, so for the case number 1, so m1 and m2 are two distinct roots. So the linear combination or the general solution for case 1 would just be, I'm just going to have it as y is equals to c sub 1 e raised to m sub 1x plus c sub 2 e raised to m sub 2x, wherein m sub 1 and m sub 2 corresponds to the real roots. Okay, so for the coefficient of the differential equation. So meaning those are two distinct roots. So we are just going to add arbitrary constant c1 and c sub 2. And then for case number 2, when b squared is equals to 4ac, so that means the two roots are just exactly the same. So when I say exactly the same, so both have the same value, but then we have to make sure that the signs are equal as well. So both of them should be positive or both of them should be negative. And then for the solution, so that would just be y is equals to c sub 1 e raised to m sub 1x plus c sub 2 x e raised to m sub 2x. So meaning we are attaching x or we are multiplying x. So for the exponential function, so whenever that would be repeated roots. Okay, so for the last one, so we have a complex roots. So the complex roots comprises of the real part, which is the alpha, and then the imaginary part, so which would be the beta. So in identifying as that is a case 3, so we have to take a look at b squared and 4ac. So if b squared is less than 4ac, then that makes it a case 3. And then for its solution, so the linear combination of the two solutions, so would be c sub 1 e raised to alpha x and then cosine beta x. So wherein alpha would be the real part and beta would be the imaginary part. And it's always a combination. So if we have the cosine and then we have the sine as well. Okay, so for the solution of a second order differential equation whose roots are complex. Okay, so for higher order, so let's say we have order 3, 4, 5, and 6. So it's just the same as long as the roots are distinct. So that would just be an exponential function and then raise it to the roots times x. Then if it is repeated roots, so if it is repeated roots, so they have the same exact value for the exponential function, and then we are just multiplying x for the first root. Okay, if there are three the same roots, then for the last one, so we multiply it with x squared. So increasing power for the x. And then for the complex roots, so it's always a pair. It always come in pair. So C1 and or for cosine. Okay, so let's have our first example. So we are to find the general solution of a second order differential equation here. So which is y double prime plus 5y prime plus 6y is equals to 0. But then let's try to classify first. So what case will it fall? So that is by looking at the relation of b squared and 4ac. So b here is 5. So that would be 5 square. And then we'll have 4, a is 1, and then c is 6. So b is the coefficient of y prime, so a is the coefficient of y double prime, and c is the coefficient of y. So that will make it 25, and 4 times 6 is 24. So 25 is greater than 24. So therefore, it falls under case 1. Okay, so if this is case 1, so that means we're expecting that should be a distinct roots. So we can do this one by factoring. But then, so we need to convert first the derivatives into its equivalent, or the differential equation into an equivalent algebraic equation. That is y double prime, so will be transformed into m squared. So the derivatives would correspond to the power of the given term. So for example, if it is a second derivative, so it will be m squared. And then for y prime, so it would be m raised to 1, or that would just be plus 5m. And then for y, so that is the constant. Okay, so 6y then will be plus 6 is equals to 0. And then we can find the roots of these. So by factoring, okay, so we can factor it out. So that would be m and m. So the factor of 6, so that will yield 5m, so will be 3 and 2. So that would make it positive and positive. Okay, so that would make it m. So 3m plus 2m, so that would make it 5m. So thus we could have then, so m plus 3, so will be 0. So therefore our first root, so will be negative 3. Then m plus 2 is equals to 0. So our second root would be negative 2. So if we want to double check it, so we can use our calculator. So we can go with our menu, and so it depends on your calculator. So this is a 991 EX. So we go to equation. So in this case, so this would be the equation, and then we select that one, and we could go with polynomial. Okay, so polynomial is 2. So what would be the degree? So this is a second degree polynomial, so we select 2. And then from here, so it would show 0x squared, so we just write the coefficient. Okay, so the coefficient here is 1. So we type 1, then equal sign, and then for x, so that would be 5 equals, and lastly, so we have 6 equals. And from there, it would show that x1, so they are just interchanged, so which is negative 2, and equals another press equal sign, which is negative 3. So which makes it correct. Okay, so negative 2 and negative 3. So we can now write our, so since that is a case 1, so distinct roots, so our general solution then, so y would be c1 e raised to negative 3x plus c2 e raised to negative 2x. And that will comprise our general solution. It is okay as well if that will interchange. So let's say y would be equal to c1 e raised to negative 2x plus c2 e raised to negative 3x. So it's fine. Okay, so it's just the designation of the arbitrary constant. Okay, so that's our first example. So for our second example, so what case would that be? So again, so for b squared and for ac, so our b is negative 6 square, and for our a is 1, so c is 9. So 6 squared is 36, so 4 times 9 is 36 as well. So that makes it equal. So since that is equal, then that is case number 2. Okay, so that is the same root. Okay, so our answer here should be the same root. So we could transform this one into its equivalent algebraic equation. So this is m squared minus 6m, and then plus 9 is equals to 0. So we can factor this out. So m and m, so the factor of 9, so we could have a 3 and a 3. So to get a negative 6m in between, so I could have a negative and a negative there. So that would make it, so m1, so which is equal to m2, and that would be equal to positive 3. So in your calculator, so you can double check. So this is 1. Okay, so let's do it again. Polynomial 2. Okay, so the coefficient is 1 equals, and then negative 6, and then we have positive 9. As you can see here, so we have 3. So it will not show two values of 3, But then you have to take note that if it is a second order, so there should be the same, or there should be two roots. Okay, although in using the calculator it only shows a single root, so that means that's a repeated root. So it will not show that there are two threes there. Okay, but then we know that that is a second order differential equation, so therefore there should be two roots. So, but on the calculator, it will only show a single root. Okay, so that means it just repeated. So our M1 and M2 is the same, so which is 3. So in writing our equation, the general solution then so would be C1, so e raised to 3x, then plus C2 e raised to 3x as well. But to make this one linearly independent, so we attach x there. So that is to differentiate one root from the other. So our general solution then so would be C1 e raised to 3x plus C2 x e raised to 3x. And we enclose our final answer in the box. So that is our second example. So how about for the third one? So third one is a second order equation as well. So let's try to find the relation, so to classify its roots. So we have b, so which is negative 4, then square, so 4, a is 1, c is 5. So this is 16 and this is 20. So 16 is less than 20. So therefore, it falls under case 3. So if it is case 3, so then we can so this is a complex root. Okay. So since this is a quadratic, so we can use the quadratic formula. So our m then so will be equal to the negative b plus and minus the square root of b squared minus 4ac all over 2a. So m then would be negative b, so which is negative 4 plus and minus the square root of b squared, so which is negative 4 square minus 4 times a, which is 1, c is 5 all over 2 times 1. So our m then would be 4 plus and minus the square root of, so we have 4 square, which is 16, so minus 20, so 16 minus 20 is negative 4 all over 2. So m then would be equal to, so 4 plus and minus the square root of negative 4. Square root of 4 is 2. And we have negative, so that would make it imaginary. So that would be 2i divided with 2. So our m then so will be equal to, so 4 divides 2 is 2, so plus and minus I. So that would be our roots. So in this case, so let's try to see. So if we have, let's try to check. So I'm using our calculator, so I'll have 1 and then negative 4 and then I'll have positive 5. Okay, so as you can see there, our first root is 2 plus I. Then our second root is 2 minus I. So from here, so we can now say that our alpha, okay, so alpha is equals to 2 Then our beta is equals to 1. So the beta is the coefficient of the imaginary part. So it's just I. So the coefficient is 1. So beta is 1. So therefore, we can now write our equation then. So y is equals to C1 e raised to alpha x. E raised to our alpha is 2x. Alpha is 2 and then multiply it with x. And then I'll start with cosine beta x. So beta is 1. So that would just be x. And then plus C2. So we just copy and then we change it to sine x. And that is for case number 3. So that is for complex roots. Okay. So how about for example number 4? So for number 4, so it's still a second order. So I'll have a b square and 4ac. So b is 0. Okay, so we don't have y prime, so the coefficient is 0. And then for our a is 1 and then c is 20. So obviously, so 0 is less than 80. So again, so this is case number 3. So for case number 3, so for quadratic, so we use the same formula then. So m then, so will be equal to, so negative b. So negative, that is 0, b is 0, then plus and minus the square root of b squared. So 0 square minus 4 our a, or instead of using quadratic formula, so the easier one would be to transform, of course, first this one into an algebraic equation. So m squared, and then that would be plus 20 is equals to 0. And then m squared then, so would be equal to negative 20. So m would be the square root of negative 20. So m will be positive and negative. So negative 20 is the same as 4 times negative 5. So m then will be equal to positive negative. So the square root of 4 is 2. And then the square root of negative 5. So we can remove the negative. Okay, so square root of negative 1 is the same as I. So that would make it 2 the square root of 5 times I. So in this case, I'm not sure if it will go on the same way. So y double prime, so or m squared, our coefficient is 1. So this is 0. Oh, what happened? And the last one is positive 20. Okay, so we have x sub 1 would be 2 square root of 5i. X sub 2 is the negative. So from here, we only have the imaginary part of the complex number. So that means our alpha is 0. And then our beta is equal to 2 the square root of 5. So we can write now our general solution to be c sub 1 and then e raised to I could move it up. Okay, so e raised to alpha is 0, so 0x, then cosine 2 square root of 5 times x plus c sub 2 e raised to 0x sine 2 square root of 5 times x. So finally, so y, so e raised to 0 is 1. So it's just c1 cosine 2 the square root of 5 times x plus C2 sine 2 to the square root of 5 times x. And this will be our final solution. Okay, so it is possible that for a given equation, even though it is a complex number, okay, so it's just it only contains the imaginary part of the complex number, and if the real part is 0, then we treat it as 0. So exponential function, so e raised to 0 would just be equal to 1. Okay, so another example, so using a denotation, okay? So that only means the power so correspond to the derivative. Okay, so this is just the third derivative of y, so minus y, okay? Or the first derivative of y, I mean. So the third derivative of y minus the second derivative or the first derivative of y. So to solve this one, so since this is already cube, we cannot use our relation to right away classify the roots. So we just need to find the roots, and then from there, so we write our solution. So this one would be m cube, and then this is minus m is equals to 0. So m cube, then minus m is equal to 0. So how do we find the solution of these? So that would be m. So we can factor out m, and then I'll have m squared minus 1 is equals to 0. So m squared minus 1 are the difference of two squares. So that would just be m minus 1 and m plus 1 is equals to 0. Okay, so that would give us the roots. So our m1, so m is equals to 0. Our m2 will be negative 1. So transpose it will become positive 1. Then m3, so would be positive 1. It will become negative 1. So we have three roots, three distinct roots, 0, 1, and negative 1. So we can verify that one again. So using our so this would be a second, it's a third order or third degree polynomial. But then so we have m cubed, so which is 1. X squared is 0. X squared is 0. And then this is negative 1. Then we have 0 for the constant. Okay, so x cubed minus x. Okay, so that's our first root, so which is 1. The other root is negative 1. And then the last one is 0. Okay, so we have so we have positive 1, negative 1, and 0. So how do we write? So y would just be the same as case 1. So c1 e raised to 0x plus c2 e raised to x plus c3 e raised to negative x. So y then would just be c1 because e raised to 0 is 1 plus c2 e raised to x plus c3 e raised to negative x. And so that would be our final solution. So this is a simpler, okay? So we just need to know how to factor it out. So for example number 5, it's easier. It's because m is common. Okay, but then for this example number 6, So I do have d cube. So it will become m cube, then minus 13m, then plus 12 is equals to 0. So in here, I cannot factor this out. So since m is no longer common to the three terms, so unlike on the fifth example, but for cases like this, so we can use the trial and error method, and that is through synthetic division. So in synthetic division, I'm going to write all the coefficient. So I'll have m cubed, so the coefficient is 1. Then the coefficient for m squared is none, so which is 0. So we don't have m squared. And then for m, so we have negative 13, and then we have positive 12. So for the synthetic division, so we're just going to do a trial and error. Okay, so our objective here is for the last term, so once we algebraically add it, so the answer should be 0. So if the answer is 0, then that makes it as a root. If it is not, then we try another one. So usually we start with 1. I'll just start with 1. I'm not sure what's the answer here. So 1 as the root. So what I'm going to do is I'm going to bring this down first, so which is 1. And then I will multiply 1 to 1. So 1 times 1 is 1. Then I'm going to add 0 plus 1 is 1. Then I'm going to multiply it again. So 1 times 1, it's still 1. And then this would be negative 13 times 1, or plus 1 would be negative 12. Then negative 12 times 1 again. So that would be negative 12. And as you can see here, 12 minus 12 is 0. So since there's no remainder there, so that means 1 is a root. So 1 is a root. So next, it's already quadratic. So we have 1, 1, negative 12. So we can still proceed. If it is negative 12, I think it's a 4 and a 3. Okay? So that the difference would just be 1. So let's try to see first. If, for example, if I'll try another one. So if I'm going to try another one, let's say another root that I want to try is 1. So I'll just bring down 1. So 1 times 1 is 1. So 1 plus 1 is 2. So 2 times 1 will be 2. So as you can see here, it's no longer 0. Negative 12 plus 2 is negative 10. So since it is negative 10, so therefore, that is not a root. Okay, so that's not a root of the remaining. But as you can see here, so since this one becomes 0, so the degree, so from a third degree, so this one is equivalent to, actually it's the same as, this is for m squared this time, this is for m, and then this is the constant part. So if I'm going to transform this one into equation again, so this is the same as m squared, and then plus m, then minus 12. Okay, so as you can see here, so the factor of this, so to get a positive m in between, so would be 4 and 3. So positive 4 and a negative 3. So therefore, I'm going to try positive 4. So bring down 1. So 1 times 4 is 4. So 1 times 1 plus 4. Oh, is that correct? So 4 times 3 is 12. Oh, it should be negative. It should be negative 4. So negative 4. So 1 times negative 4 is negative 4. So 1 times negative 4 is negative 3. So negative 3 times negative 4 is positive 12. and thus making it equal to 0. And lastly, the other one would be, I think it's positive 3. So bring down 1. So 1 times 3 is 3. So negative 3 plus 3 is 0. So as long as the last term is 0, then that makes it as a root of the equation. So thus, we can now write that our m1, the first root is 1, second root is negative 4, third root is positive 3. So we can check that as well. So let's say I have a 1. So for this is 0, and then m is negative 13. So negative 13, and then we have positive 12. So our first root is negative 4. So this one is negative 4. The second root is positive 3. And then the last root is positive 1. And as you can see here, so the 3 are distinct roots again. So therefore, y then will be equal to c1 e raised to x for the second root. So c2 e raised to negative 4x, then plus c3 e raised to 3x. And that will be our general solution for example number 6. So again, so we can verify this one with our calculator, so whether our answers are correct or not. So for fourth order, okay, so this is d to the fourth plus, okay, so converting this, so we can convert this as m to the fourth plus 3 m cubed plus 3m squared plus m is equals to 0. So again, m here is common to all, so I can factor out m. It would make it m cubed plus 3m squared and then plus 3m. Or still have 1. Last 3m and then m and m, so would be plus 1 equals to 0. So m cubed plus 3m squared plus 3m plus 1. So one of the factor is m. And then for m cubed, I do not know. So we can use again quadratic. So look at this. M then will be equal to 0. So if I'm going to start right away with synthetic division, so this how am I going to write this? As 1, a 3, a 3, a 1, and a 0. So for the first one, I'll start with 0 because I already know that one of the root is 0. I'll bring down 1. 1 times 0 is 0. So 3 plus 0 is 3. So 3 times 0 is 0. So 3 plus 0 is 3. So 3 times 0 is 0. So 1 plus 0 is 1. So 1 times 0 is 0. So 0 plus 0 is 0. So therefore, one of the root is 0. How about the second one? So since everything is positive, so 1, 3, 3, 1, so I'll assume for a negative 1. I'll try negative 1. I'll bring down 1. So 1 negative 1 is negative 1. So 3 minus 1 is 2. So 2 negative 1. 2 times negative 1 is negative 2. Then 3 minus 2 is 1. And 1 times negative 1, it's negative 1. So 1 minus 1 is 0. So again, so negative 1 is a root. So I have 1, 2, 1. So 4, 4. Okay, so this is m squared plus 2m plus 1. So therefore, a factor of 1 is just 1. So to get a positive, so I should have a negative 1 again. So bring down 1. 1 negative times negative 1 is negative 1. So 2 minus 1 is 1. So 1 times negative 1, it's still negative 1. So that makes it 0. And lastly, obviously, it's another negative 1. So bring down 1. 1 times negative 1 is negative 1. That makes it 0. So giving us as m1 is equals to 0. So m2 is is the same as m3, and it's the same as m4, which is negative 1. So as you can see here, so this is case 1, and then this one would become case 2. So 3 repeated roots. So to write our equation then, so y would be equal to c1 e raised to 0x, and then plus c2. So next we have a negative x. Okay, so c2 e raised to negative x. But then since this is repeated, so I'll have x e raised to negative x. And then for the third repeated roots, so c3, I'll have x squared e raised to negative x. As you can see here, the first repeated root, so would just be x raised to 0. Okay, so which is 1. Then I'll have x for the second, and then for the third is x squared. If we have a fourth, that would be x cubed. If we have the fifth, that would be x to the fourth, and so on. So y then, so e raised to 0 is 1. It's just simply c1 plus c2 e raised to negative x plus, okay, my constants are not correct. So plus c3 x e raised to negative x, and then plus c4 x squared e raised to negative x. So this, okay. This is our final answer. By the way, I haven't checked so whether this is correct or not. The good thing is for this calculator, so it could have until the 4th degree. Okay, so I could select 4. M to the 4th is 1. The cube is 3. So m squared is 3. And then we'll have 1. But then we have 0 for the constant part. So that's x sub 1 is 0. And we have negative 1. And since that is repeated, so that means the last 2 so would be negative 1 as well. So again, so you can see that in here, so x sub 1 is 0 on the calculator. So x sub 1 is 0, so that's the first root. For the second root is negative 1. So x sub 2. So since this is a 4th degree equation, so supposedly, so there should be 4 roots. But then it's only showing 0 and negative 1. So that means the last part is the one that is repeating. So in this case, x sub 2, x sub 3, and x sub 4 are all negative 1. Okay, so that's our example number 7. for example number 8, so we have m to the fourth plus 2m cubed plus m squared is equals to 0. So I guess we can do factoring here. So m squared is common. So m squared. Then I'll have m to the fourth divided with m squared is m squared. Then plus 2m. And then plus 1 is equals to 0. And I can factor out this one as m squared. Then m, this is 1 and 1, so plus and plus is equals to 0. So m plus 1 times m plus 1. So in short, our m1 here is the same as m2, so which is 0. So which is taken using this. And we have the m plus 1 is equals to 0. So the third or m3 and m4 is the same, which is equals to -1. So we can verify that. So using this as 1, okay. And then m cubed is 2. M squared is 1. And this is 0. 0 as well. So therefore, we have x1 which is 0. And x2 should be -1. x2 is -1. And it won't show. And okay, so that's the problem with this calculator. It will not show which will repeat. Okay, so which number will repeat. But in this case, as long as you know how to factor it out or how to use the synthetic divisions, it will clearly show what are the roots. Okay, so in this case, so there are two case 2s. Okay, so we have m1 and m2 which is 0 and m3 and m4 which is -1. So therefore, I could write my answer. So C1, so supposedly that would be e raised to 0x. E raised to 0 is 1. So that would just be C1. Then plus, so since this is repeated, so I'm going to attach x. Okay? And then e raised to 0, which is 1. And then the last one is -1, so which is a distinct or repeated roots for -1. So I'll have plus C3 e raised to -x. And then since -1 is repeated, so I'm going to attach x. So C4 times x e raised to -x. So C1 plus C2x, that is for the roots of 0. And then C3 e -x plus C4x e raised to -x, that's for the roots of -1. And that will be our final answer. So homogeneous equation are simpler. So it's just a matter of factoring it out. Okay, so this is the limitation of the calculator. Okay, so the limitation of the calculator. So since this one is only limited up to fourth degree polynomial. So in this case, this is a fifth degree polynomial. So we don't have a choice but to use synthetic division here. So this is m to the fifth. So plus 5m to the fourth minus 2m cubed minus 10m squared, then plus m plus 5 is equals to 0. So I'll write 1, 5, a -2, a -10, a 1, and a 5. Okay, so trial and error. Again, I'll start with 1. So bring down 1. 1 times 1 is 1. So 5 plus 1 is 6. 6 times 1 is 6. Negative 2 plus 6 is positive 4. 4 times 1 is 4. 4. Negative 10 plus 4 is negative 6. Negative 6 times 1 is negative 6. This would be negative 5. So negative 5 times 1 is negative 5. That becomes 0. And next, I'll try another one. So bring down 1. 1 times 1 is 1. So this is 7. 7 times 1 is 7. This is 11. 11 times 1 is 11. This is positive 5. And then positive 5. That makes it 0. Next. So since everything is positive, I'll try negative 1. So 1, negative 1, a 6, a negative 6. 11 minus 6 is 5. So 5 times negative 1 is negative 5. So that makes it 0. So negative 1. So 5 and 1. Okay, so we could try another negative 1. And negative 1, so I'll have bring down 1. Negative 1, so 6 minus 1 is 5. Negative 5, that makes it 0. And of course, so finally, so that will be a negative positive 5 and negative 5. I could have a negative 5. So bring down 1. So negative 5, 0. So our M then so M1 is the same as M2, which is positive 1. Our M2 is the same as M3, or M3 is the same as M4, which is negative 1. And then our M5 is negative 5. So if you have equation like this, so let's say you were able to get the first root already. So in this case, the first root is 1. So assuming that that is correct. Okay, so the first root is 1. And then you have a calculator, so wherein the fourth degree is possible. So if the fourth degree is possible, so the coefficient that you're going to include this time, so would be this one. Okay, so after subtracting it, okay, so from the original coefficient. So in this case, so this is already a fourth order or a fourth degree equation. So that's to check so whether this 1, -1, -1, and -5 are correct. So I'll start with 1. So this one, so this is 1. And then I'll have 6. Then I have 4. And I'll have a -6. One, 6, 4, -6, and a -5. As you can see here, so we have a positive 1 as our x sub 1. X sub 2 is -1. X sub 3 is -5. Okay, so that's the only problem. You will not know so which one repeated, but it shows 1, -1, and -5. So the one that repeated is -1, and we don't have an idea about it unless we're going to do the synthetic division. So our final answer then, so for our solution, so it's a repeated root for m1 and m2, so that would just be c sub 1 e raised to x, and then plus c sub 2 x e raised to x. Okay, so as for repeated. And then for m2 and m3 and m4, which is -1, so plus c sub 3 e raised to -x plus c sub 4 x e raised to -x. And lastly, plus c5 e raised to -5x. And that one becomes our okay. So this is our general solution then. So for a fourth or fifth order. And for our last example, so this is a sixth order differential equation. So we have, this is m to the sixth minus 2m to the fourth minus 7m squared minus 4 is equals to 0. So using synthetic, so this would be 1, 0 for m5, then -2 for m4, m3 is 0, m2 is -7, m is 0, and then a -4. Okay, so again, we always start with 1. So bring down 1. 1 times 1 is 1. This is 1. 1 times 1 is 1. -1. This one is -1. This is -1. -1 times 1 is -1. This is -8. -8. -8. -8. Okay. So it's not a root, so 1 is not a root, so we delete it. So I'll try the -1. So this is 1. 1 -1 is -1. This is -1, -1, -1, positive 2. This is 0. 0, -1 is 0, so 0. 0, -1 is negative. So 1, 0, -1, positive 2, 0, 0, 0, 0, -1 is 0. So -7. So -7 is positive 7. So this is 7, negative 7. Again, it's not 0. So we delete. So we proceed with 2. So that's how we do trial and error. So we bring down 1. 1 times 2 is 2. So this is 2. 2 and 2 is 4. This is 2. 2 and 2 is 4. This is 4. 2 and 4 is 8. This is 1. 1 and 2 is 2. So 2. So 2 times 2 is positive 4. And that is 0. Is that correct? So 1. So 2 times 2 is 2. 0 plus 2 is 2. So 2 times 2 is 4. Negative 2 plus 4 is 2. So 2 times 2 is 4. 0 plus 4 is 4. 4 times 2 is 8. Negative 7 plus 8 is 1. 1 times 2 is 2. So 0 plus 2 is 2. Then 2 times 2 is 4. Negative 4 plus 4 is 0. Okay, so this is a fifth order now. And next is... Oh. I'll try 2 again. So I'll bring down 1. So 1 times... So everything is positive. So if it is 2, so 1 times 2 is... I think this should be negative. So 1, negative 2, negative 2, 0, 0, positive 2, negative 4, 0, 0, so 1, negative 2. Okay. So I'll have a positive 2 and a negative 2. So 1, negative 2, 0, 0, 2, negative 4, 0. 0, negative 2 is 0, 1, 0, 1, negative 2 is 0. Okay. So I'll have m to the fourth, m squared, and m. So this is the same as m to the fourth plus 2m squared plus 1. So I think I can factor this out as m squared and m squared plus 1 plus 1. So that would give us... Okay, so I'll stop there. And then I have converted this into this one. So this is m to the fourth. And then 0 for m cubed. So it will just become 2m squared and then plus 1. Because this one will... So that would be complex roots. Okay. So this would be m squared plus 1 is equals to 0. So m squared then will be negative 1. So m would be the square root of negative 1. So in short, m would be equal to positive negative I. So in short, we have m1, so which is 2, m2, which is negative 2, and then our m3 is the same as m4, And it's actually the same as m5, and it's the same as m6, because m squared plus m1, or sorry, uh, it's the same as positive negative I. So for our solution then, by the way, so let's try to check. So using our calculator, so I can check up to the fourth degree. So I'll check this one, so which is 1, 0, the other one is 2, 0, then the other one is 1. Okay, so I have positive I and a negative I, and it's repeated. So therefore, this would be y is equals to, so c1 e raised to 2x plus c2 e raised to negative 2x plus, so our alpha here is 0, our beta is 1. So therefore, plus c3 cosine x plus c4 sine x. But then since this is repeated, so I'll have plus c5 x cosine x plus c6 x sine x. Okay, so that is for repeated roots, repeated complex roots. Okay, so it's a combination, repeated complex roots. So we have distinct roots for 2 and negative 2. And then we have a complex root, so cosine and sine. But then it is a repeated complex root. So that makes it c5x cosine 5 or cosine x plus c6x sine x. And that will be our final solution. Okay, or that's the general solution. Okay, so that is homogeneous equation. So this is how to do it manually, but then we can always use our calculator so to verify our solution, so whether that is correct or not. Okay, so we still have to show the solution. So the calculator will just be used to verify so whether our solutions are correct or not. And that will be all for homogeneous equation. So good day and God bless always.